My name's Laura Neely, and I want to be a nuclear engineer. Nuclear engineers research and develop the process, instruments, and systems used to benefit from nuclear energy and radiation. Nuclear engineers work in a variety of settings, like the medical field, nuclear weapons, radioactive waste, and power plants. For this project, I will focus on those who work in power plants. Nuclear engineers in power plants are almost always on their feet, checking pressures and temperatures and making sure they aren't changing, as well as using logs and looking over trends from several days to make sure there are no variants. Nuclear engineers work long 12-hour shifts to make sure that the power plant is up and running. Nuclear engineers are vital to society as nuclear power plants supply about 13% of the world's power, and the numbers will only increase as the world of nuclear engineering is said to grow. So what high school classes can help you prepare to be a nuclear engineer? Well, taking classes like AP Bio, Physics, and AP Calculus would definitely give you a good foundation for the classes you'd have to take in college. So what does a college schedule look like for nuclear engineers? So this is a layout of the courses you would take in college to be a nuclear engineer. Freshman year, you would take classes like chemistry, calculus 1 and 2, and engineering classes for like scientists in labs. You would also do like computer environment and stuff like that. Sophomore year, you would continue with like your calculus classes, so you take calculus 3, and you would also get into more like in-depth engineer classes like engineering statistics, engineering dynamics, nuclear engineering, engineering and scientist labs, physics, stuff like that. So junior year, you're really going to dive into the nuclear energy part of the engineering. So you're going to focus on like fluid mechanics, structure, property of energy, nuclear reactions, reactions and analysis, and stuff like that. So senior year, you're basically going to wrap up taking the classes you need in order to get the degree in nuclear engineering. So you'll take like reactor energy, reactor systems, you'll take like some safety classes in radiation, you'll take some tech classes, and you'll take electives, obviously. And basically you need 121 credits to get the degree in nuclear engineering, at least. So what colleges am I looking at going to, and what scholarships do they offer me? So the first school I'd probably apply to would be NC State. And NC State offers a Duke Energy Scholarship, which varies in money they will offer you. And you can get this through PACAssist, which is a student scholarship interactive search tool that NC State has made available. The next school I would apply to would be Georgia Tech. And although Georgia Tech offers multiple engineer scholarships, one of the best ways for me to afford Georgia Tech would be to apply for the Provis Scholarship, which provides 40 freshmen that are non-residents out-of-state tuition waiver for 8 semesters. So this would mean I'd only have to pay for books and housing. The next school I would apply to would be the University of South Carolina, and although they offer smaller engineering scholarships, the best scholarships are their top scholar awards, which includes scholarships like the Stamps, McNair, and the Horseshoe Scholarship. They are awarded to out-of-state students who have a strong academic record and are leaders in their school and community. So after college, where will I go? What places could I work? Well, I could work for the company Duke Energy, which is actually headquartered in Charlotte. I could work for the company Exelon, which is an American Fortune 100 energy company headquartered in Chicago, Illinois. I could work for the Southern Company, which is an American gas and electric utility holding company based in the southern United States and is headquartered in Atlanta, Georgia. I decided to interview Jacqueline Holzhauser, a nuclear engineer who graduated from NC State with a Bachelor of Science in Nuclear Engineering. The pictures below are pictures from her radiation training that she did to work at her power plant. Jacqueline decided she wanted to be a nuclear engineer because in high school she loved science and math classes and she really didn't like history and English. The power plant Jacqueline works at is called the Regina Nuclear Power Plant in Wayne County, New York. Jacqueline said she'll work multiple days of 12-hour shifts, but they're followed by 8 days off, and that she also goes every 5 weeks for training, and that she loves her job even though it can be stressful because she's always moving around and she's always doing some kind of math or science. So since Jacqueline works as a equipment operator at the power plant, she doesn't do as complex of math as you would find in the control room. So she's going to do a lot of heat transfer problems that use formulas. And the one she gave me says calculate the rate of heat addition for a heat exchanger operating with these conditions. And it says the coolant temperature is 535 degrees Fahrenheit. The coolant temperature out is 551 degrees Fahrenheit. The coolant flow rate is 7 times 10 to the 7th IBM over HR, and the coolant specific heat is 1.3 BTU over IBM degrees Fahrenheit. So as you can see, the formula you would use to solve this equation is shown. and Q is the total heat added in BTU. Cp is the specific heat in BTU over LBM, so Fahrenheit, and triangle T equals change in temperature, degrees Fahrenheit. So this is Jacqueline's work for the problem. You can see we're trying to find Q. We're given that M equals 7 times 10 to the 7th IBM over HR, that Cp equals 1.3 BTU over IBM degrees Fahrenheit, and that the change in temperature is the temperature out minus the temperature in. So you would plug it in. So Q equals 7 times 10 to the 7th IBM over HR times 1.3 times 551 minus 535. So when you plug that all in, you're going to get Q equals 1.46 times 10 to the 9th, and since IBM and degrees Fahrenheit units cancel out, you're left with the unit BTU over HR. So that wraps up my video for nuclear engineering. Thanks for watching.